In this video, we're going to be looking at writing expressions and equations given a statement. So before we get into that operation, let's take a look at a couple definitions to kind of really frame out what we're going to be talking about. So the first thing we want to talk about is a quantity. Now, quantity is anything that can be measured or counted. So this could be the number of people in a room, the number of shoes in the room, something like that. Anything that you can count is a quantity. Now, the thing that we really care about in algebra is something called a variable. Now, a variable is an unknown represented by a letter. It could be represented as a symbol. If you want to get crazy, you could use a star instead of an X, but we typically use letters. And these are used to represent unknowns, things that change over time or something that we're trying to solve. Now, expressions and equations are really what we're going to focus on in this video. So an algebraic expression is a mathematical statement using at least one variable. So for example, if I wanted an algebraic expression, I could write, for example, x plus 2. And that is an algebraic statement or expression. So we could use that as our example. Now, a numeric expression is what you started with back in elementary school. And this is a mathematical statement without any variables. So if I had, for example, the classic 2 plus 2, that is a numerical expression. You use those basically all of math, so that is what that is. Now, an algebraic equation is very similar to an algebraic expression, except there's one big difference. So algebraic equation is a mathematical statement that has at least one variable and an equal sign. That is the key. You have to have an equal sign for it to become an equation. So if I were looking at the example of x plus 2, if I had x plus 2 equals 5, we would say that is an algebraic equation. Now, continuing with definitions, we've got a few more. So here I have an example with an algebraic expression. So I know it's an expression because there is no equal sign, and I see the variable x. The next term we need to know is constant. And you may hear the phrase, let me write this down for you. You may hear the phrase constant term. That is going to come up quite a bit in algebra. So a constant term are numbers. They're not variables. And the word constant means to stay the same. So in this example, my constant would be 13. 13 is always going to mean 13. We know what that represents. If we were to count it out, we know what 13 is. So that is never, ever going to change. So that's why we call it the constant term. So it's just the number. Next, we have the operations. Operations are basically the verbs in math. It's what you're doing. So in this example, we have addition, subtraction, multiplication, and division. Not all in this particular example, but those are the big operations. We have addition, subtraction, multiplication, and division. So there are others you could look at, but they really all kind of derive from addition, subtraction, multiplication, and division. So we won't go too in depth here. So if I'm looking at this example, I actually have two operations. I see here that I've got addition there, and right here, I've got multiplication. Remember, when you have a number in front of a variable, that means you are multiplying those two things together. There's actually two operations happening here. Now, another term that you need to know that is really, really, really important is this thing called the coefficient. Now, the coefficient is the number directly in front of the variable. So this arrow actually kind of does double duty here. So this is multiplication, but 4, that number right there, is the coefficient. In algebra, it is incredibly important to know that that is the coefficient. We're going to talk about combining like terms later, and you need to know what those are. Now, when we're looking at the operations, one of the trickiest parts of math is knowing when to use particular operations when you're looking at word phrases, because there are a lot of different words that mean the same thing. So I've got a little chart here to kind of help you organize what is what. So if I'm looking at addition, the big ones you're going to see are sum. That one's kind of been a big one. Make sure it's a U. A more than, so I'm talking about more than something, and total. And I put this one in red because a lot of times in word problems, you're going to talk about a total of things. So if I'm looking at the total of number of people, I could add the number of boys, the number of girls, and I could get a total. So that word typically means addition. We've got subtraction that represents difference, less than, minus. Multiplication could be said with product times. Division, you could say divided by or quotient. There really aren't that many other ones. And then you've got equal. And the big ones here, you see the word is or is equal to. Notice that word is involved in both ways to say it. Now, the one I want to really kind of give you a heads up on are subtraction and division. So be careful with those because the order the words are written determine how you write the expression. So when we're talking about the difference of something or the quotient of something, it matters how you place them. So for example, if I were to do 4 minus 2 and 2 minus 4, those are not equal to each other. So it matters in which order you put subtraction and division. So if I did 4 over 2 and 2 over 4, again, those aren't equal. This is 2, this is 1/2. So when we do division, in particular with the word quotient and the word difference, we go from left to right with how it is written on the page. So let's do a couple examples and see what we can come up here. So what we're going to do is we're going to translate these phrases into mathematical expressions. So when we start these problems, we want to work from left to right and see what there is. So the first part, we see the sum of a number x and 19 is equal to 47. Okay, well, let's dissect this and see what we come up with. So first of all, I see the sum. So the sum tells me that we're going to be dealing with addition. So I see here I'm adding. Now, when I see this phrase, a number x, this simply means just the variable x. That's not, we know that x isn't actually a number, but here it represents a number. It's an unknown we don't know. So the sum of a number x and 19. Okay, we can do that. So sum, so I'm taking x and I'm adding 19. So the next part of the phrase is equal to. Hopefully that's a dead giveaway that you're going to put an equal sign. And it is equal to 47. So there we go. We did the sum of a number x. A number x and 19 is equal to 47. Let's try another one. We've got the difference of negative 18 and a number m is 91. Okay, so we've got the difference. So if I look at that back up my chart, well, I know that's subtraction. So the difference of negative 18 and a number m. Well, again, number m, that's my variable. So I know that just represents m. So this is where the order matters here. And when we're talking about difference, we write from left to right. So it's going to be negative 18 minus m. Now this word is. This implies an equal to. In this particular case, it does. Is equal to 91. So there we go. Let's try some more. So for the next one, I've got the sum of 9 and the quotient of 94 and a number t. Okay, so what I want you to do is pause the video and see what you come up with, and I'll go over in just a second. So let's give this a go. So this one is a little bit more complicated because I see a couple of operations. So first of all, I see the sum. So that tells me adding. The sum of what? 9 and the quotient of 94 and a number t. Okay, so now I see quotient. So that tells me division. So I'm going to have some adding, I'm going to have some dividing. So I'm going to kind of work backwards here. So I'm going to add 9 to this quotient. So let's do the quotient. 94 and a number t. So that means t. So we're going to go from left to right here. So since we've got 94 first, that's going to go on the top. And then t goes on the bottom. Now I'm going to find the sum of this. So I'm going to add 9. So you can write it this way, or you could write 94 over t. With addition, it doesn't matter. You could flip the order, and it's still the same. So hopefully, you came up with this response. If not, we'll try again. So here's another example. I want you to pause the video, give it a try, and I'll go over it in just a second. So let's get to it. So again, I see here that I've got a couple operations. I see product, which means multiplication. Now, as a heads up, in algebra, you don't want to use x's to represent multiplication. It gets very complicated when I want to do something like 2 times x, because then which one's the x and which one's not, it's a hot mess. So we avoid using x's for multiplication as much as possible. So I see the product of 5 and the sum, that's adding, of 2 and a number x is 19. So that is here implies an equal sign. Now this one didn't have an equal sign. It didn't say is, so I had no equals up here. So is 19. Okay, well, let's start with the sum. So the sum of 2 and a number x, so I know sum is 2 plus x, and I'm going to multiply it. So the product of 5 and this sum. So what I'm going to do is I'm multiplying the entire sum by 5. So it'll be 5 times the entire thing, since I'm multiplying the sum, is 19. Okay, so I've got 5 times the whole sum, and it equals 19. Let's do 2 more. So I want you to pause the video and try the first one. So let's give this a go. So 19 more than the product of 5 and a number y. Okay, so let's think this through. So I know there's no equal sign here because it doesn't say is or is equal to, so I know this is going to be an expression. So let's start in the beginning. So more than, if you look back at that chart, that implies adding. The product we know is multiplication of 5 and a number y. So let's start with the product. Okay, so we're going to work a little bit backwards. So the product of 5 and a number y is 5y. Now with variables and numbers, we can just write them next to each other, and that implies multiplication. So if you want, you could put like a little dot in the middle and say 5 times y, or you could just write 5y. Now if I'm doing 19 more than that, well, if I want to show more, I'm just going to add 19. So let's think about it numerically for a second. What is 19 more than 5? Well, if I add 19 to 5, it's 24, which is what I want. It's 19 more. So that's what I come up with, 5y plus 19. So it's more than the product. Let's try another one. So I've got 10 less than the quotient of a number t, and 15 is equal to 100. So again, I want you to pause the video, try it, and see what you get. All right, let's get to it. So I've got 10 less than. So I know it's going to be very similar to the first one, but this time I'm going to be subtracting. So I think at the end I'm going to be doing minus 10 at some point. So we'll get to that in a minute. Next, I see quotient. Quotient tells me division. A number t, remember that's our variable, and 15 is equal, see that is, equal to 100. So I know the whole thing is equal to 100. Excellent, I know that. Now let's deal with the quotient of t and 15. So t over 15. We go from left to right. So t is on top, 15 is on the bottom. Now 10 less than that. Do we put the minus on the front or at the end? Well, we're going to put minus at the end because I'm doing 10 less than this quotient. So for example, if I wanted to do 10 less than 15, we would subtract 10 at the end to get 5. So if we want to think about it logically, that's why the 10 comes at the end. So those are some brief examples of writing expressions and equations. Now there's one last thing we need to cover, and that would be inequalities. Writing inequalities are the same thing as writing expressions and equations. Now they have different uses. They're not the exact same thing, but writing them is very, very similar. So let's review the symbols. So first of all, we have a less than symbol. We have this little arrow pointing to the left. If you hold up your left hand, it looks like the little V created by your pointer finger and your thumb. So that's why I remember L is less than. So it looks like your left hand. Next, we have greater than. It's flipped the other way. So if the mouth is opening to the left, that means it is greater than. Next, we have less than or equal to. That little bar underneath here implies equal to. That means I could write something, for example, 2 is less than or equal to 2. Now, it would sound weird if we said 2 is less than 2 because that's just weird. A number isn't less than itself. However, a number is less than or equal to itself. That's okay. We have greater than or equal to. Now, the key for these problems, because a little bit ago we saw a problem that said less than. So how do we know if it's less than or is an inequality? So are we subtracting or are we dealing with an inequality? Now, the word you want to look for is the word is. kind of hard to say. You're looking for the word is, because is implied it was an equation. It's also going to imply that it's an inequality. So that's the big word we're going to be looking for. So let's do 2 examples and then we'll wrap it up. So let's write the following phrases as mathematical expressions or equations. So the product of a number y is less than 42. Okay, so product I know is multiplication. So the product of 19 and a number y, we know at this point this is our variable. Now here's that word, is less than. So this tells me it's going to be an inequality. And less than we know is the sign that looks like our left hand, is less than 42. Wonderful. Now conversely, we have 42 less than the product of 19 and a number y. So this is not an inequality because what word is missing here? It's the word is. Since I don't have the word is here, it's not an inequality. This is just going to be an expression. So 42 less than is going to be subtracting. So I'll have minus 42. The product, remember this is multiplying, 19 and a number y. So 19y minus 42. So you see here how the word is makes a huge difference in determining whether it's an inequality or an expression.